What we're going to do now is calculate the velocity of the character. And the way we're going to do this is by calculating the difference between where the character was in the previous frame to where they are currently, and figuring out the time that has passed between those 2 points in order to calculate the movement per second, which is velocity. So just to demonstrate how this will work, let's say we have a character here, and he's moving to the right. So right now we know that he's here, but let's say that 1 second ago he was here. So we can use that to calculate the difference between here and here. We can see how far he's travelled. So let's say that's 100 units. And if we know how long it's been since this last update, so we know that that was 1 second ago, we can calculate the speed by knowing the distance that has been travelled and the time that has been travelled. So in this case, he will be moving at 100 units per second. However, you are not usually checking once per second, you'll be checking a lot more frequently, so at whatever FPS the game is running at. So if the game was running at 100 FPS, that means that every 0.01 seconds we have an update, so the animation will be updating. So that means that the last time that we checked where the character would be was probably very close to where he is now, so practically overlapping in position because this was only 0.01 seconds ago. So the same logic applies where we will check the difference between where the character is now and where the character was on the last update, and we'll use this as the distance, and then we will check the time between the current time and the previous frame, also known as delta time. And the way that we're going to convert this from how far he's travelled in one frame or within the delta time to a velocity which needs to be in units per second is we just divide one by the other. So we take the distance and divide it by the time that's passed, and this will give us the speed in units per second. So once we know the speed of the character in units per second, this allows us to make predictions about where the character will be. So to take our first example where he's moved 100 units in 1 second, we can take a guess that in another second, so 1 second into the future, he will have moved by the same amount in the same direction. Or in this case, where we only know 1 frame worth of movement, we can predict 1 frame into the future. Or we could still predict 1 second into the future using that same information, but our prediction will be less accurate because we're guessing what's going to happen in the future, and this assumes that the character is going to keep moving at the same velocity in the same direction with no other changes. However, this is accurate enough for us to be able to predict where the character's feet should be placed in order to anticipate the movement of the character. So if it's moving in one direction, we can place the feet in the direction of that movement. And whilst the character is actually transitioning from one position to another, we can still update that prediction if it's making some minor changes or minor adjustments. So it's not locked in stone once we make the prediction, and we can continue to update it whilst the animation progresses.